What's up, mathematicians? Welcome to section 1.7, part 1.7a. This is going to be the first day. This is, wow, this is a doozy of a section, just thinking about what we all have to, so I definitely decided to split it up into two different days. And this is first day. We're just going to talk about equations, and then next video we'll talk about inequalities. So absolute value equations. Let's review, what is absolute value anyway? There's two different kind of ways of thinking about it. And an absolute value is a number's distance away from zero on the number line. It is also the positive version of any number. So for example, and it looks like this with these two lines. These are absolute value lines. If you want to take the absolute value of 5, the number 5 is 5 units away from 0. Negative 5 is also 5 units away from 0. So they both share the same absolute value, 5 and negative 5. When you take their absolute value, you get 5, both of them. It's also the positive version of both of these numbers. The positive version of 5 is 5. The positive version of negative 5 is still 5. So that's what absolute value is. Quick refresher. We're going to start solving equations that have absolute values in it, and it's a little dicey, a little tricky. So stay with me. The solution set. Here's we've talked about already inequalities and equations that have more than one answer. So most of them so far have only had one. We haven't had to worry about this. If you want to report the solution set, it's a collection of all of the solutions. So here's a super complicated equation that you won't have to solve this for months. X to the fourth minus x squared equals 0. What numbers satisfy that equation? There's actually 3 of them. 3 solutions. You can take your pick, any one of these. You can put into here, into this equation, 1 or negative 1 or 0. They all work. You know, if you put in 0, 0 raised to the fourth minus 0 squared is still equal to 0. There are 3 solutions, and so in math, whenever we ask a question and there's 3 answers, we got to report them all. So that's what that'll look like, and it's just these curly brackets, and all the solutions are separated by commas, and it doesn't even have to be in numeric order from least to greatest or anything. Any order is fine. But as we've seen so far, there are equations out there that have no solutions, and so when you have to report the solution set, sometimes there's nothing in it. It's like an empty grocery bag. You haven't started shopping yet. An empty set is a set with no solutions. So for example, these curly brackets, there are 3 solutions here, and there's no solutions here, 0 of them. And so therefore, this is what it could look like. There's a symbol. You just draw a 0 and then slash it out. That's also the same thing, commonly known as the empty set. So for example, this equation right here, there's no real number that satisfies this equation. So what is the solution set? It is empty. No solutions. So here's the big technique for today. That's all kind of like preliminary stuff. But in order to undo the absolute value, I've seen plenty of students actually, when they're solving these, they just erase them and pretend they're not there. You can't erase the absolute values. What you really need to do is take the next step and replace them with plus or minus x. Some people call this a plinus, plus or minus. Get it? Not that funny. All right, so let's solve. I'm thinking of a number, and the absolute value of that number is equal to 5. Well, you might say, Berg, we already went through this. There's 2 of them. The answers down here are going to be 5 and negative 5. And you'd be right. What I want to do is I want to develop some techniques right now that are going to scale up. Let's get into the habit of doing some of these things here now, even when the problem is easier, so that when the problem gets harder, you have something to fall back on. So what I'm saying is, although you could just visually look at this and say, I think it's going to be 5 and negative 5, and you'd be right, here's what the habit is that's going to help us when things get a little bit harder. We're going to replace the absolute value of x with plus or minus x. That means there's going to be 2 cases. There's going to be the positive version of x or the negative version of x. And so then we actually found one of our solutions right here. And then if we want to multiply both sides of this equation by negative 1, we would get the second one. We've got our 2 answers, and we're going to report them in a solution set, like that. Like I said, order doesn't matter. You could have written curly bracket 5, comma, negative 5, close bracket. Let's do another one. Here, I'm seeing 3 times the absolute value of x minus 5 is equal to 7. Well, undo the stuff on the outside. Let's add 5 to both sides, so we get 12. And then let's undo the multiplication that's not written right here, but it's 3 times the absolute value of x. So you get that after dividing both sides by 3. Now we're going to, in order to undo the absolute values, we have to do the plus or minus thing. We need a positive version and a negative version. The positive version, the negative version's over here, and the positive version's over here. This is how we get our 2 answers. We have to split it up. So then, let's multiply both sides by -1 over here, and we get this. So reporting our solution set, it's +4 and -4. Okay, so here was an example of an equation that has absolute value and all this other operations outside of the absolute value. Let's do let's see what it looks like on the inside. So the first thing I'm going to do, and the reason I'm doing this first, the reason I'm going to undo the absolute value first is because it's on the SADMEP order of operations, it's on the same level as parentheses. So let's undo what's inside the parentheses first, and then we'll undo the subtraction, and then we'll do the multiplication. Okay, so let's take a look. If we're going to undo this, we have to replace the absolute value with plus or minus, and it looks like this. The entire contents of the absolute value gets replaced with plus or minus. Remember, whatever numbers we come up here, if it's going to be positive 12, that's here, it's good. And if it's negative, all of this is 12, then that's going to also satisfy the original. Because this 4x minus 8 could be just -12, and then when you take its absolute value, you would find that it is equal to 12. All right, so let's split this up. The plus or minus both sides. This is going to be the positive version. 4x minus 8 is equal to 12. Or negative, parentheses, all of this. The negative version would look like this. And I know that's a little hairy, but it's something that I think we can deal with. Here we go. Let's do the positive version first. We have to add 8 to both sides, and we have to divide both sides by 4, and we get one of the answers, one of the solutions. Here, I think what we have to do next is distribute this negative to both terms on the inside. So when you distribute, you get -4x, and here, negative distributed to a -8 turns into a +8. Let's undo the addition, let's undo the multiplication, and we get our answer, and we report the steps, 5, -1. I know it's really tricky. I think if we see some more examples, then we'll get the hang of it. Big idea is you can't just erase the absolute values. If you want to undo them, you have to replace it with plus or minus, which will split up into 2 different solutions. Let's take a look at this one here. Absolute value of x is equal to -5. Berg said that what we got to do is replace the absolute values with plus or minus x. But let's go back a second. Let's use our intuition. Which of the numbers up here, when I take their absolute value, you get -5? Well, neither of them. Not +5 or -5 when you take their absolute value. Do you get any negative number? Actually, it turns out that here is another example of an equation that has no solution. Boom. It is I'm going to report the empty set. You're like, well, here, there's an equation, and I want you to fill this collection, this set, with all the solutions. And I say, well, there are no solutions. And if there's no solutions, you can write this symbol. This is the empty set with no solutions. Here's a shortcut for recognizing this kind of red flag situation. If you take the absolute value of anything, and that equals a negative number, that's a big red flag. You want to stop what you're doing, and then just write empty set, there's no solutions. Going any further than that is going to be kind of a waste of your time. So let's check this out. Okay, so this is pretty complicated. We've got the absolute value of 4x minus 7 plus 10 is equal to 2. Your audio check for today is the fact that I was in the engineering club. They didn't have robotics in my high school. I would have loved to have been in robotics. However, they did have an engineering club, and we sat around and talked about engineering stuff, and then studied, and eventually took a big test at the end. It was way more fun because we ordered chicken wings and pizzas and stuff like that to be delivered to the actual competition area. It was amazing. We got into a little bit of trouble though. Engineering club, that's your audio check. All right, so here, in this problem, we saw operations on the outside, and on this problem, we saw operations on the inside. We have to do this really in a very careful order. We have to first isolate the absolute value stuff. Take care of the outside operations, take care of the absolute value, take care of the inside. We're working order of operations backwards. Because if we were doing PEMDAS here, we would say, like, let's say this is not an equation. Let's say it weren't equal to 2. Let's say we had a number for x and it was, I don't know, some number. But the first thing we do is multiply by 4. Then the next thing we do is subtract. And then after that, we take its absolute value. And the last thing we do would be add 10. When we're solving, we have to go in reverse order. So the add 10 is not the last thing to do, but it's actually the first thing to undo when you're solving. It looks like this. We're going to undo the plus 10 by subtracting 10 from both sides. And then, wait a second, I was about to undo this absolute value, but I see this. I see anything, the absolute value of anything equals a negative number. That's a red flag. It doesn't matter what number we dream up for x to be here. At the end of the day, when we take the absolute value of all that stuff, it's never going to equal -8. So, red flag, no solutions. You can just say it's the empty set. There are no answers. There are no numbers that satisfy this original equation. Okay. Ooh, there is a lot going on here. I think what I want to do is I have to remember here, I'm going to isolate the absolute value. I'm going to undo all the outside stuff first. So that looks like, I'm going to combine these terms that are on both sides. This minus x is not inside the absolute value, so I can move that around if I want. I'm going to add x to both sides. Then I'm going to undo this times 2 by dividing all the terms on both sides by 2. Tricky, because this x plus 1 is really grouped into one term. At the biggest level, there might be 2 terms here, 4x and 4. There's actually only one giant honking term over here on the left. They're grouped together. So I'm going to divide this whole term by 2 and this and this. That'll cancel out the times 2 and turn this into 2x and 2 over here. Notice I'm not dividing the 1 by 2 or the x by 2. I'm dividing the whole term. All right, now we've got to undo the absolute. Next, we've got to replace the absolute value with plus or minus x. That's how we're going to undo it all. So this used to be absolute value, now it's plus or minus. And so I'm going to write both the positive version over here and the negative version over here. Let's solve the positive version first. I think I'm going to subtract x from both sides, add 2. This is what we get. Over here, I got to make sure I distribute. So I've got to get rid of the parentheses by distributing. And then notice that it didn't just turn the x into a negative x, it also turned the plus 1 into a minus 1. All right, still we have variables on both sides, so I'm going to add x to both sides. And this is the 2x becomes a 3x. And now I'm going to add 2 to both sides. And divide both sides by 3, and you get this. Now, there is only one solution. It is 3. Turns out, and I'm not going to do all the work here because the video is getting long enough, but if you plug 3 into this original equation, it will work. 2 times, 3 plus 1 is 4, absolute value is still 4, times 2 is 8, minus 3 is 5. But the left-hand side is 5 when this is true. So, and then 3 times 3 is 9, minus 4 is still 5. So 5 equals 5. Actually, 3 works. But if you were going to do the same thing with 1/3, it doesn't work. You might be able to put in the 3, but you can't put in the 1/3. So so we have to cross this out and not report it as one of our solutions. Here's a new idea. The new idea is called an extraneous solution. This is a real solution, and this one over here is the extraneous solution. An extraneous solution is a potential solution that isn't an actual solution. In this section, it can occur when there are variables both inside and outside the absolute value. So as soon as you start seeing inside and outside the absolute value, you got to start checking every single one of your solutions. Yeah. Because the equation is getting tricky enough. It's not that I did something wrong. I followed all of the algebraic the rules that I've been all taught and everything like that. It's just that somehow, for some reason, and maybe a more complicated reason that I'm willing to discuss here and now, this actually is not going to work. I can show you the more complicated reason in class, if you like. So what you've got to do is check all the potential solutions in the original equation and only report the ones that work. This one works, this one doesn't. All right, so it looks like we're in the same boat over here. I see a variable inside, I see a variable outside. So we're going to have to eventually check anything that we come up with. Let's see, I want to isolate the absolute value. That means get rid of all the outside stuff. So I'm going to, let's see, I have to undo the multiplication and subtraction. I'll do the subtraction first by adding 9 to both sides. And now I'm going to undo the times 2 by dividing all the terms on both sides, the 26, the 4, and this giant term here. It's only one term, the absolute value groups it all together. So when I divide both sides by 2, this is what I get. Now, in order to undo the absolute value, I'm going to replace it with the plus or minus. Positive version over here, negative version over here. We've got to solve them one at a time. I see variables on both sides, so I'm going to subtract 2x from both sides. And then I'm going to subtract 1 from both sides. And I'm going to divide both sides by 3. And I get x equals 4. Here, I think the first thing to do is going to be to distribute the negative. So you get negative 5x minus 1, and then 2x plus 13. What do I want to do? I think I'm going to add 5x to both sides. And then I'm going to subtract 13 to get negative 14 is equal to 7x. Dividing both sides by 7, you get negative 2 equals x. So we've got two solutions here, 4 and negative 2. Turns out they both work. When you plug the 4 into the original, it does happen to work. And then when you put the other solution in here, it also happens to work. I want you to figure out what the red dot is covering up. What number is there? Both of these, there are no extraneous solutions. Both lines of logic lead to an actual solution. Thanks, y'all. Have a great day, and I'll see you in class.